Hello, mic check. Okay. So, so in the yesterday's stream, uh, sorry, the day before yesterday, I stopped after solving one of the lead code problem, and I realized that without knowing the data structures, and I can't go directly to solving problems. So today, I will cover most of the data structures starting from a linked list, then doubly linked list, hash table, stacks, queue, and binary search tree. So let's get started. So starting with linked list. So I will first create a linked list.py in which we will define the linked list class. So to the linked list, I imagine it as a train which has a engine and other uh, and then what they are called. I forgot what it is called, but the compartments are connected or coaches are connected to the engine. So that is how linked list looks, or I imagine it. So each compartment it can be called as a node, and the engine is a head. So first we need to define the node, which is class node, and we will define the init method. So when creating a node, we need to pass a value to it. So self.value equals to value, and each node has some next element, or the next element could be none as well. So the last element will not have any next value. So this is our node. Then class linked list. While creating a class, we also need to pass a value. Then new node, we will create a node first, node with input value. That will be our head engine. So every time we create a linked list, the first node is a head. And then we keep adding new nodes to it. So tail is also a new node because it is a single node. Then length equal to 1 because it is a single. Then to print out, we will write a function. So whenever we call this function on a linked list, it will print all the elements inside linked list. So one by one we will get a value in a temp variable, and using for loop, sorry, not using for loop, while loop. So while this temp is not empty or is not none, we will keep printing and we will keep moving forward. So we will print temp value of temp, and then we will move our temp to the next. So temp equals to temp dot next. So that is how we move forward. this function will print out the list. Then other operation which uh, we can perform on a linked list is to append. So while creating, we created only a single node, but let's say we need to add more items to the linked list. Then in that case we need to have that append function, self comma value. So append will also take some input value which we will be appending to the linked list. So we will create new node equals to node using the input value. Then uh, let's say if the length is if the length is uh, 0 or none. So if someone has created an empty linked list, or somehow that linked list has become empty, and then someone is trying to create a new item, then we need to have that condition. If self.length is none, we will make head and tail as the new node. Tail will also be the new node. Else, if already some items are present in the linked list, then we will add the item to the end. So self dot tail dot next equal to new node, and we will also point the tail to the new node. So we added new item in the end, and we updated the tail to the new node. So and now after adding the new item or new element, the length has increased, so we need to update that as well. So which is plus equals to 1, and then just return true. So this function will add new item to our linked list. So let's print out whatever we have done till now. So let's say first we will create a linked list with one single item. So let's say n equals to linked list with one item which is 3. So this will create a new linked list. We'll just print it out and we'll check. Yeah, so here you can see new linked list we have created, and it has the print function has also printed the value within the linked list. Then let's say we add new item 5 to it, and then try to print it out. Sorry, my bad. Yeah, so this print statement has printed out 1 3. Then this print statement has printed out the complete list after appending, which is 3 and 5. Then another function which we can have is prepend, similar to append, but before that maybe we can write one function which is pop to remove item from the list. So there are two similar functions. One is pop, then pop first. So pop will remove the last item, and pop first will remove the first one. And there is another remove function which can remove any item in between. So first I will write pop. It won't take any input value. This function will be directly called upon a linked list, and it will remove the item, or it will give return that item. So first condition will be what will happen in case the linked list is empty. So if self.length equals to 0, then simply we will return none, because there no items are present in a list. Then we will get the first. Now we want to return the last item, but to get the last we need to iterate through each of the item. So first we will take a head in a temporary variable, and we need to have the previous value of uh, the item as well. So which will also be self.head initially, then while iterating we will update it. So now we need to perform while loop till we reach the end value. So while temp.next, so while the temp.next has some value, we will iterate. Then the previous will become our temp, and the temp will become temp.next. So we will keep iterating till this becomes none. So once this thing becomes none, we will get the previous and the last value. So last value will be in the temp, and value previous to the temp will be in the pre variable. Now we have got the values. So the tail we can update. So the previous value now we can make it as a pre, and the next value we can make it none, because we are going to remove that value next to pre, which will be the temp. So we need to pop that. So self dot length we can now -1, because we have updated our code, or updated our linked list. So here also one thing we need to do is, in case if after removing the length becomes 0, in case the length becomes 0, uh, we can make head equals to none and tail also none. Sorry, tail. And simply we can return temp. So temp is our the last value. So this is the pop method we have written. Now let's test it. So if we print end.pop, it should give us 5. So it should remove the last value. Oh, something went wrong. Okay, we are returning temp. Actually, we should, if we return the temp dot value now, then we will be able to see the value. But we can, instead of doing that, we can just print our linked list. So yes, now you can see here, after popping, uh, we can see here it has printed only 3. So we created linked list with 3, then we printed, so that is the first 3, then we appended 5 and then again printed. So 3 plus 5, then we printed what we have popped, but it didn't get printed because we are returning an object, not a value. So if we print returning temp dot value, then it would have printed 3, sorry, it would have printed 5. But After that also we are again printing linked list. So here you can see 5 has been removed. So this thing is working. Maybe I will remove the in between print statements, so in the next time we can see the proper results. I don't have to give the complete explanation what is happening. Hmm. Then like append we will write now prepend. So if we want to add item at the beginning of a linked list, then we can use this function. So we will take input value here, then create a new node using that value, similar to what we did in the append. New node equal to node using the input value. Then first condition, if length is 0. So what can we do in case of empty? Definitely self.head equals to new node, and also self.tail equals to new node. Then if case, in case it is not 0, in that case uh, our new node dot next we can write as a self dot head. So next item to the new node will be current head, and then head will be our new node. So very simple. And then just self dot length we need to update, which is plus equals 1, and then just return true. Yeah, that's it. So this was the prepend. Similar to pop, again we need to pop first, then we can write that method as well. It won't take any parameters, only just self. If length is 0, that will be our initial condition. We are just returning none because there is nothing to pop. Temp equal to self dot head, because this is what we want to pop. Then we need to update self dot head to the self dot head dot next. So the next value to the head we are going to reassign as a head. Then temp dot next we will make none, otherwise it won't pop, it won't return a single item if we won't make it none, because the next item will have something attached to it. Self dot length minus equals 1. Then in case the length becomes 0, we just need to update self dot tail equals to none, and just return the first value. Here also the temp, if we try to print out, it will give some memory address like this. But if we return temp dot value, then that direct print statement will work perfectly. I'm not going to test it out because I know this is going to work. Then there are a few more functions that we can write, such as get, to get value at particular index. Okay, so let me just think. So definitely here we will need a for loop to iterate through, And then one condition we might need to apply, like what will happen if the index is index is 0, sorry, less than 0 or greater than the length of the linked list. In that case, we will have to return none. Otherwise, we will iterate through the linked list and find the item at the given index. So till that we will just go, we will do dot next, dot next, dot next until we reach that particular index. So let's write it down. So if index is less than 0 or index is greater than or equals to, I will have to write, because our starting index is 0, so greater than equals to, I will have to take. Otherwise, in case someone gives input index value, index value equals to value of total length, in that case the for loop or the last the item will be none at that position. If you do one more iteration, just return none. Else, in the else block we are going to do for loop, and temp equals to, we will start with self dot head and we will apply for loop. So we don't need that I, so that's why we are using underscore in range of index, which is the input value. We will just do temp equals to temp dot next. Once this for loop is done, we will just return the value. So that's it, nothing else, very basic. Then set, just like we have removed one value, we can set a value at particular index. So self comma value comma index we can do. So we will follow the similar approach, like temp equals to self dot get. Now we will utilize the earlier function to get the value at the given index, and we will update that value. So if temp has some value, then temp dot value equals to the input value. That's it, very basic code, nothing we have to do. So if we followed the same approach here, that would also work, but we don't want to write all this thing again and again. So we can directly utilize the already implemented function in here to get the value of this index and just update its value to the new value, and then return true. So in case temp has no value, we can return false. So when the temp will not have value is in case the index is less than 0 or greater than or equals to self dot length. In that case, this gate will return none. So if it is none, then we will also here return false. Similar to set value, there is one more function, insert. If you don't want to update value at a particular index, rather we want to add one value at particular index. So this function is for that. So to do this, mm, first thing we can do, which is this same condition which we used to get. So because we are here also giving index as input, so I'll write that first. If index less than 0 or index greater than. Now here we won't be using greater than or equals to, because uh, even if it is equals to self dot length, we can just add one more number, and dot next we can make it none. So there are two special conditions uh, we can write. One is at the zeroth index, and one is at self dot length. So if index is 0 or is self dot length, then in that case we can just utilize the earlier methods, prepend and append. So if why it is going here, prepend we will have to do. And then comes the else block. So if index is not in the one of the above, then in that case we need to create a new node. Node with the input value. Then we need to make space for this new node. So, and where we will want to make a space is um, at the index before uh, sorry, index. So I have that idea in mind. I might not be able to explain it properly, but I'll write it down. So temp equals to self dot get we can do. So we will get item before index minus 1. So first we will get item before the index where we want the new item. Then new node, we need to have the next value of value to the node. Dot next equals to our temp dot next. So I hope you get it. Here this is a little bit difficult to understand what we are doing here. We took item previous to the index where we want to add a new item, and then um, for the new node we need to have the next value, which will be our value next to that this temp value. Little bit difficult to understand. Maybe with the help of diagram I would have it would be easier, but you have to think in the mind how this part is working. Then temp dot next we can update to new node, and then just simply increase the length. Return true. Yeah. So this can insert a new item to the list. So this is where we made space. So in similar way, while writing one of the program two 3 days back, I was in the similar situation where I had to add new item. So at that time I could have used this kind of logic. So def remove. So in case if you want to remove some value at particular index, this will be this will also on the similar approach like the insert. I will just copy paste the above code, and then I will proceed. I don't want whole code, but I want the conditions. So in this case, instead of append, we can use pop first, and here we can use pop method, and then else block we need to write. So again, I am going to get mm, this similar to this. I will get the value previous to the index. I will mention it as a prev, that will be easier to understand. Then we will store it in temporary variable, the next value to the previous. So we took out the value to the prev, and the next value we are keeping in temp. So this temp will be the one which we want to actually remove. So in that case, uh, now I got the value, but I need to update the original linked list. So item next to this prev, we need to keep item next to temp dot next equals to temp dot next. Now we can make our temp as empty. Sorry, item next to temp we can make it none, because we want to return the single value. So it is kind of breaking the loop. Minus equals 1 and return temp. Then there is one function to reverse the linked list. Mhm. Temp equals to self dot head. So we will iterate using for loop in the range. So now self dot head we can update to the tail. Okay, and also self dot tail will be our temp variable. Once that is done, now I need to reverse the inside elements. So for that, this logic I read earlier, so I know I will explain it after writing. So after equals to temp dot next and before equals to none. So what we are going to do is we will go next. So temp has our head item, and we are going to find the next element to the head, and we will keep on going, and we will update the new one using that. So you will understand once I write the for loop. For I don't want the I in range of self dot length. So this is kind of reversing. So as you can see here, I mean this until this part it is easy to understand. Self dot head equals to self dot tail and tail equals to temp. So we have updated head and tail, but the remaining part which is in between the variables, so that we are updating over here. Okay, wait a minute. Mm, temp. I mean this will work. I This logic is little bit complex to understand. Mm, okay, I will just keep as it is. We can debug and we will understand how it is. Like we can add breakpoint and understand how it works. I'm not be explaining. It is little bit difficult for me to explain as well. We will move ahead to the doubly linked list. So this will also have most of the methods which we have, or most of the functions which we have wrote in the linked list. Only difference is that doubly linked list has prev element. Right now we just went dot next dot next dot next, but in case of doubly linked list it has prev, so we can do from the both side. So here, this was the additional thing which we do in the doubly linked list. It's prev. Then our actual class, it will also take a value while creating. So new node equals to node with input value. Then self dot head we will update. Self dot tail we will update, and self dot length we will update. Yeah, so we have defined the class. Then for the printing, print list So this won't take any parameter. We'll take the head first, and we will iterate over when we iterate till this becomes empty. Very basic. Then append. Nothing new in this, kind of repetitive, because in the linked list we did the similar thing. So this method won't change much, just the insert or remove method will be more different. Node if the basic condition, sorry, I just lost in my world. Help dot head equals to new node, sorry, what I'm doing, if is none, if head is none, then self dot head equals to new node, self dot tail equals to new node. Here we can write one more similar condition, that is length, if length is 0, but that is fine. Last time I used that method, so now different one. So self dot tail dot next equals to new node, and new node dot prev. So here that prev comes into picture, equal to self dot tail, and self dot tail equals to new node. Just increase the length, length plus equals 1, and return true. That's it. Then pop. Just basic condition, if it is 0, return none. Then we are taking tail in a temporary variable, because we want to return that temporary variable. If length is 1, so this is one special condition in the pop, self dot head equals to none, and self dot tail equals to none. Else self dot tail equals to self dot tail dot prev. So here we are using that prev. So we are making updating our tail, because we want to return the original tail value. Then self dot tail dot next we can make it as a none, and also temp dot prev we can make now none, because we no longer need it. And we can we can, sorry, first we need to update the length, we need to -1, and then return the temp. And this will also return the object, not actual value, so we should not try to print directly the function or the return value of the function. Instead we'll have to print the linked list. Then the prepend self comma value new node equals to node with the new value if just a minute. Hmm. If self dot head is none, self dot head equals to new node, self dot tail equals to new node, else temp equals to self dot head. So we need to make space for the new item, so that's why first we kept the head in the temporary variable. Then here we are updating the next value of our new node to the self dot head, kind of redirecting or relinking we are doing here. Next value we added, and the previous value of self dot head also we are updating here to the new node. Now we can safely update the head to new head or new node. Then the remaining method similar to pop, diff pop first. This feels kind of useless, but I'll write it just to have all the methods for doubly linked list together, so we can revise it afterwards anytime we want. We can just go through the classes and check out the logic. If length equal to 0, we just simply return none. Then take the head in a temporary variable which actually we want to pop, so we are going to pop the head. If it is 1, then make everything else 0 or none. Else self dot head equals to self dot head dot next will be our new head, and self dot head dot pre we can make the new sorry, the none, because we are going to pop the pre value. And temp dot next also we can make none, so that chain will break. And self dot length minus equals 1, then return temp. So that's how we can pop the first item. Then define the get method, self comma index. So this is a useful method because we can use it in the set also. if index is less than 0 and or index greater than equals to self dot length, return none. If index, no, here one thing we can do, as we have the prev and the next, we can utilize to quickly find out the required variable. So it will it become, so the our searching time becomes half, because we can do this self dot length by 2. So if index is less than length by 2, we will search in the first half. So temp equals to self dot head, and we can apply for loop for underscore in range of index temp equals to temp dot next. Else, if it is not in the uh, if it is not less than half, then we will look into another half using the prev. So temp equals to temp dot tail. So we will start looking from the end. So for loop will also go in the reverse for underscore in range self dot length minus 1, we will do not from the length, comma index. So total length minus 1 till the given input index, and we'll start iterating in reverse using minus 1. So temp equal to temp dot prev. This we will loop and simply return the temp. So this will take little less time, so it will take half time, instead of doing in only going one way. Shit, what happened? Shit. Nothing special in the set value, but still there is this looks like similar to linked list, but it will take a lesser time to execute. So this one is more complicated, uh, as we need to update both prev and next. So you will have to uh, put little efforts in understanding. So we want to insert new value, so we will have to make space for it. Index less than, so this is the default condition, so those three conditions we will need to have here, because we already have append and prepend that we can utilize. So in else we will create the new node using our node class, share the value with it, and so before or pre we can get using self.get index -1. So one index before the index at which we want to add the new element, we are keeping it in before. So after will be before dot next. Then now comes the point new node dot prev. So here we found in which two elements we need to add the new node. So we need to add the new node in between before and after. So new node dot prev will be our before, sorry, and new node dot next will be our after. Okay, also we need to update before dot next equals to new node and after dot prev to new node. Not much difficult to understand once you have the concept in mind. Sorry, before dot prev, not after dot prev, to the new node. Then self dot length, which is basic thing, is equals 1 and return true. That is it. Then the remove function. So now we want to remove that temp variable. So before removing, we need to kind of relink the items previous to the temporary variable and next to the temporary variable. So that we are going to do it here. So temp dot prev dot next will be temp dot next, and temp dot next dot prev will be temp dot prev. So very easy to understand, nothing complicated. You should get this point very easily. So now just remove the elements as we have reassigned those. So temp dot next will also be null, and self dot length also minus equals 1 and return the temp. So this is done for the doubly linked list. Then there is a stack and queue. I guess first I will go with queue, then I will go to stack. As a queue, I mean kind of a line of people we can imagine, and it will uh, it will add item from the front and remove from the other end. So there is enqueue and dequeue function. So enqueue will take some value in input, and dequeue just remove the last one. Sorry, I said the other way. Dequeue will remove the first item from the queue, and enqueue will attach one more to the end. So this will also have a node. So let's start queue. Div node, no, class node. So in case of linked list, we had head and tail, but in case of queue, we don't have those. Instead, we have first and last. So you can imagine it as a singly linked list as well. So this is very basic. That's why I'm not explaining anything. I mean, we have already wrote that print print function in linked list, doubly linked list. This was the third time. In queue, it's kind of a append, I would say. that's it for the queue. Very easy. In the dequeue, we need to remove the first element, so that we took in the temporary variable. If the length is 1, then just make first and last to none. If it is not none, then first we need to update. So the first will be self.first.next, and the next item to the temp variable, we make it none before returning, otherwise it will return the whole lot of a queue. So that is it. So here we are just breaking the link. So this was the queue. Then stack. Stack is uh, how you can imagine. Mm, you can imagine a stack or books kept one on each other. So a book on a book on a book. So in case of the stack, we can keep item above the stack or remove item at the top of the stack. So only two methods to the stack: push and pop. So there is no bottom end we can use. So we can't perform any action on the bottom end. And one more thing is, stack has height than the length. And one more thing, stack has top. Even though it don't have any bottom variable, it has top. So we can perform action only on the top, and we can update height as well. So if we add new item, then we can add one to the height. If we remove one item, we can decrease the height. So I hope you understood what we are doing here. We are adding new node. So we created a node, then checked the height. Uh, if there is some height, it is so if height is non-zero, then we are adding new node to the top, and we are updating next value to the new node to the current top value. In case the height is 0, the top will be our new node, and here in the end we are just updating the height variable. So pop will be exactly opposite to this. I'm not performing any operations on the stack. You can try to create a stack on your own, and you can print it out, then push one item to it, print out, then again pop, and then print. So you can try it out on your own. You will get it. If I give all the code, you won't understand how to do things on your own. So stack queue is done. Then there are two things remaining for today. One is hash table, and second one is binary search tree. So out of these two, binary search tree, I have a proper knowledge, but hash table, uh, mm, how to create the hash, that function, I myself won't be able to tell you. I'm just referring to the notes to write that hash function. But for the binary search tree, I can write it on my own. So bst.py we will start. So binary tree. So you can imagine a kind of a structure. So it has so let's say it is kind of a pyramid. So at the top there is one item, then the top item will have two childs, which are two nodes connected to the top one. Then these two will expand to 4, then 4 to 8. So it goes on increasing, so it goes on doubling. So that's how that binary search tree looks. The tree actually can have multiple nodes, but this is binary, so each parent will have two. So let's write the class for binary search tree. So while creating the binary search tree, one thing we should always keep in mind that uh, the greater value is always on the left, and the lesser value is always on the right. So the topmost is the root, and root will have left, right. So anytime we are going to create a binary search tree, or we are going to initiate the binary search tree class, it will be empty in the beginning. Then using this insert function, we are going to add the items to it. So the basic condition will be, initially it is empty, so we will have to assign the root to the new node. So first I will create the new node. If help dot root is none, which means our tree is empty, then self dot root equals to new node and return true. Okay, then temp equals to self dot root. In case it is not empty, then we will have to iterate through our binary search tree and then add the node. So we will apply while loop to find the exact position to add the new node. So if new node dot value is equals to temp dot value, will we won't be doing anything, we will just return false. Okay, then there are two more conditions, if greater and if lesser. So first, new node dot value is lesser, uh, is less than temp dot value. In this case, then again we need to check if if there is any space left or not. So if temp dot left is none, we'll add that node over there. And return true. Else, if it is not none, then we will just update our temp equals to temp dot left. Then the second part, else block. If else means if the value is greater than the temp dot value, then in that case we need to go on the right side. So if temp dot right, we will check the right one is none or not. If it is none, we will just update. And return true. And if it is not none, then we will update temp to the right. We will go more on the right. So yes, so this is the code to insert a new item. And then another is kind of a searching we are going to do using contents to check if it contains the given value or not. Our binary search tree contains the given value or not. Temp equals to self dot root, then perform while loop until temp is not none. If the given value is less than temp dot value, this case we are going to temp dot left, we are going to left side, otherwise we will go on the right side. Greater than temp dot value, temp equals to temp dot right, we will move on the right side. Else, so if these two conditions are not matching, then definitely it is equals to, then we will simply return true, and we will return false. If we don't find that value, it will return false. Very simple binary search tree. Only thing remaining, hash table. Hash table, I didn't got it quite properly, but I understood the concept what is happening here. But how it works, that maybe I need to revise. So they say that it is kind of a dictionary key value pair structure that we store using hash in the memory. So there are in total 7 positions to store. I won't be explaining anything about it. You will have to do Google or check on the Geeks for Geeks. I have referred Udemy course to understand this concept, but still I'm not properly getting it. I'm just putting down the code so that in case going further uh, I need to solve any problem regarding hash table, I should have the basic class for it to perform any operations, or to get more clarity to solve the problem. So this will have say data map will initially have 7 empty spaces to store the new added items, and then we have the hash function. So we pass the key to the hash function and it returns some address where we will be storing the input item. So this is the function to calculate, or this is the statement which actually calculate hash using the key. My hash plus ord, which gives the ASCII value of a letter, multiplied by 23. I don't know why 23. I guess any prime number will work over here. Even in the course, he hasn't explained it properly how this part works. He just went through this. Why this function is not highlighted like this? Acha, this is not accessed, that's why. So we will be accessing that function while setting the item or getting the item. So using this hash function, we will get where we want to store the new item. It's not like I don't understand at all. I got the idea what they are doing here, because in the course he showed some diagrams to explain it. So I know how it we are storing or getting the item. Only thing which I don't get is the hash function. Why it is like that? That I don't understand. Why prime numbers? Why 7? Why ORD of letter? That part I don't get it. Similar to get item, so this will give you the value, but if you want to get keys, self. So as per my understanding, this thing will have time complexity of uh, big O of n square, because these are nested for loops, but I'm not sure if it is true or not. Yeah, so this was the hash map, which I won't be able to explain, but tomorrow I will maybe go back to it, or if in case any problem related to hash table comes, I will go through it and I will explain more properly. So yes, that's it for today, and I will end my stream here.